Hi students, today we'll discuss about the content of a fourth unit on data science. As we have covered so many concepts of data science which is newly to you, or you might have known some extent, like we have different kinds of data warehousing, data mining concept, machine learning concepts. Again, we have different kinds of data collections, right? Statistical techniques we have covered. Now, in this particular unit, we will cover experimental setups, measuring performance of a model, then interpretations of results. These are the contents of unit 4. So whatever the things we have covered till this, we have to go for, sometimes we have to go for creating a model, or sometimes we can go for different kinds of design frames, right? Design model, right? Then we have a design patterns we have, and somewhere we need to validate it, somewhere we need to measure the performance of that model, whether the correct output is getting or not, or exact output is getting or not. So in this particular unit, overall, we'll have that kind of discussions. So we'll continue. Now, this particular content comprises different types of evaluations process, then methodology process, right, of data sciences. Now we can see first, we can go for first slide. That is experimental setups. Under this, you will have a training data, tuning data, test data, then a hold out the method, cross validation method, a bootstrap method. We have different kinds of method for validating the data also, and model also, whatever the framework we have set up. So we have to validate it. So this particular unit or this particular discussions will help you to how to find out exact model, or how to validate a particular model with different validations methods, right? So first we'll see what is training, or sometimes we call it training data, or training, we can say training data. You can see in this particular slides, you can see training data is extremely large data set that is used to teach a machine learning model. Now here the point is, we have to understand what exactly the meaning of training data. So exactly the training data is, sometimes we need some particular set of data for processing, for especially for when we are going for machine learning process, or we have a machine learning model which predicts something, or which gives some decision kinds of things, or analytical result. So that time we can go for exact data we can give through some process that we call training process. Now, first, this process helps to rectify and to find out, refine the data as per the target, or as per the requirement, intended, desired target data, right? So here the training means, now you can see, if you will think about management process, right? Through training process, we can make a particular employee or a set of employees, right, into up to mark, so that they can directly deploy in the department or in the workforce mode. Now, here the point is, you can understand with the management concepts to our data sciences concepts, right? So when we are talking about training and training development process, right, we have a different kinds of HR processes, right? So under which you will have a training process, out of which, so this training, we provide training to the employees, those who are lack of knowledge, lack of what you call skills. Okay, we have to give some training. Now, after getting training, or after completing the training process, they will much more adequate. They can have some adequate knowledge. They can have some particular skills, so that they can directly they can work in the different types of departments, different types of sections, or they have a different kinds of processes they can involve. But at the before training, if you deploy them, then these employees may not work properly, or it will be a difficult task to complete or to handle the department. Now, this is one side where I am talking about the training, actually the brief importance of training in the department or in the organizations or in the process of HR, right? HRM, human resource management, right? So now come to this particular part in our data sciences. The similar kind of meaning here we can fetch and we can use in our context. Now here training data means it's we are not taking employees here. We are taking about we are particularly we are thinking about data. And when we are talking about huge set of data or huge large amount of data, right? And that data can be used for our different kinds of model, like we have a different kinds of design patterns model, we have a different kinds of machine learning model, we have expert system experts model, we have, okay, so through which we can send that data, we call it trained data. By training, okay, we can refine the data as per our need, so that we call it trained data. So that trained data can be used effectively in our different model, and then only the different model can utilize properly, or they can give different kinds of analytical solution, or it may be decision support system, or they can give some directly different kinds of decisions, that is through machines, right? So the training data is labeled, so we have to give some name to this data. The training data is initial set of data used to help the program to understand how to apply technology like neural networks to learn and produce the sophisticated result. So now here the important part is why we need training data, or why we need trained data, especially because we are going to use that data for different kinds of atmosphere. It may be a neural network where different kind of decision takes place. It may be artificial intelligence, different kinds of decisions process, and different kinds of models can be used. For it can be used for machine learning process. That can be a different atmosphere, different scenario. So every different type of computing latest technology, latest what you call a different kinds of atmosphere, that trained data can be used in a different labeled data. Different, we can label it differently. Sometimes you might have suppose the same data can be labeled, that can be named in a different manner in different context. Now for example, instant I can give an example. Now you might have studied in DBMS, right? Database management system. We call it table, right? Table, a set of rows and columns, intersection of rows and columns. That particular table can be called as a relation in relational database. Now here the context change, relational database and a pure database management system. But in database management system, we call it table, whereas that table can be called as a relation in relational database object. Similarly, that relation can be called as and dimensions we can call in our data warehouse and data mining techniques, right? So now here the labeled, the name of that same table, same information can be changed, can be labeled differently. So that's the meaning of data is labeled. Okay, so we have to give a different kinds of name for different purposes or different context. Now you observe this particular image, you can right hand side of this, you can see process, people, tools. So these are the triangular shape we have given. So some extent you have to do some task that is under process. Someone has to do something, that is your people. Then tools, you have to use some machinery equipments, you have to process. To now you think as a student, you have to write one document. Suppose what is data science? So you need some teaching aids like pencils, pen, right? Scales to draw a diagram, right? So these are the things you have to use the tools. People, that is human being. that is you as a student, you can use different kinds of teaching aids and you can make a particular presentation, you can make a particular document, you can make a particular report. So now different phases you have. Suppose if you want to make a diagram or if you want to write some theoretical part, these are the operations. These are the different kinds of processes you have. So in processes, you will find different kinds of operations such as business rules, communications protocols, and quality control. And we are focusing this particular processing into the business environment, right? So we are talking about organization and its different kinds of tasks or processes. So operations, for example, in teaching, in suppose teaching organizations like university, they have different kinds of processes, examination, evaluations, right? So these are the different kinds of operations. And we have a set of rules. We have a set of academical rules, protocols we have. Communication protocol, a higher authority can send different kinds of informations, like university can send examination date, examinations process of conducting the examination, practical, viva. These are the things we should have some proper communications protocol, and under that we can work. And quality control, you must have a quality aspects over here. Now suppose how you are conducting, how you are evaluating, that's matter, that's towards the process, we call it quality process, right? Quality control process, we can say. So now this is called process. Then it can be linked with, you can link to tools, you can link to the people, those can who can perform that process. So now here people says workforce, different kinds of human beings, those who are involved, like employees, students, okay, including workers. Then we have selections, experiences, and training. So these are the part of, you can say, people. Then come to your tools, technology we are using, right? Then different platform you are using, and we are using different kinds of data directly we are taking. So now this is how a triangular shape specifies process, people, and tools, and which gives you a particular training of data. And that can be possible. We can have some trained data out of which of this process, right? Three process. Now, once you will get a trained data, that can be used for your machine learning, that can be used for your export system, that can be used for different kinds of sophisticated technological environment, like neural networks, artificial intelligence, data-wise data mining, right? So we can use this type of data, we call it trained data, in this field, different kinds of fields. Similarly, in our data sciences also, we need training processes, we need trained data for better evaluations, for better results, right? I think this is clear. Rest of the things will be easy to understand. This is how we can define training data. So you can go for observations in training. Now you can see training data and data, test data are two important concepts in machine learning. So training data, which is called trained data, and the second one is test data, right? Which is tested or tested data, or which has been tested, right? Are two important concepts in machine learning, right? So the input and the output, the input, that is your trained data you are giving as a input, and whatever the process we have in the machine learning model, so they give you different kinds of data, or we call it result. That tested data can be useful for further decisions or further different context, right? So now here the output is very important, here the input is very important when we are having a machine learning model. So that is very important. So two aspects is very important, that is training data, and the second one is testing data or test data. The training, the observations in training set from the experiences that algorithm uses to learn. In supervised, already we have completed supervised learning and unsupervised learning, right? In supervised learning problems, each observation consists of an observed output variable and one or more observed input variables, right? So here you can see already we have completed in the previous unit, right? So supervised learning, we have a supervised and unsupervised learning when we are talking about machine learning or when we are talking about the data mining concepts, right? So that time you might have observed by putting a particular rules or by putting a particular formula or by putting in a particular scientific rules and regulations, we can make data, okay, we can make separate data, okay, so that data can be trained or untrained, we can decide. That time also supervised learning problems also gives an observations like outputs and inputs, what are the outputs you have and inputs out of inputs you can have a different kinds of idea. For example, I can say suppose the complete students in Bharati Vidyapith, I can make a rule, right? So those who are contiguously from the 10th to degree, they have a 60% mark. So now I can make refinement here. I can make a cluster here, right? By putting a particular formula, right? Or condition or restrictions. So now what happens actually, it eradicates or it gives us different kinds of groups here, right? So now which is not trained data, it is called untrained data that cannot be used. This is one group, one cluster which cannot be used for our machine learning processes, right? Different kinds of models, and which is trained data by putting different types of conditions, restrictions, or methods, or algorithms, or different kind of formulae, right? We can make a trained data, and that can be used for our machine learning process, right? So this is how we can define test data. The test set or test data set is a set of observation. Here also observations we have. Here also some learning process we are having. Observations we have. The test data set is a set of observation used to evaluate the performance. Here the part is evaluation, because test data, you have to evaluate it. Because training data may have tested or may not be, gives you accurate result or may not give you accurate result. But once you have a tested data, that means it's a concrete, valid data, right? So evaluate the performance of the model using some performance matrices. Now depends on different kinds of model, right? So we have a different kinds of model. We have a machine learning model. We have a neural networks model. We have a different data mining models. We have for designing patterns, right? So different kinds of models we have, different kinds of framework we have. So under which data can be sent, okay? That data must be training data, right? Trained data. Data can be sent and it must be tested. Once it is tested, then you can say this is test data. Now, for example, I can give you an example, very real world example, right? Now, tell me, what's the difference between very short? I will explain just for understanding, for clarity of your this particular discussions. Now, we might have used different kinds of brand garments, right? Garments, right? Like we have a different kinds of garments we use normally. So by putting a particular tag, okay, it gives a different types of quality and all these things, you know that, right? So suppose you have a different kinds. If I'll talk about especially for gents garments like shirt, t-shirt, we have Louis Phillips, we have Arrow, we have Peter England, we have different kinds of polo, right? So now these are the brand t-shirt or garments we have, right? So now if you want to test it, if you want to make, now they have a different kind of testing phases, garments companies, right? So they have, if something defects comes, they will reject directly. But if you'll see non-branded garments, they may not have a testing part. Directly they can stitch, they can make, and they can put into the phase of shipping. They can deliver that particular to a retailer and a wholesaler, right? They may not have a testing part. So once they have completed this circle logistic, so you will find defects. So you might have seen the non-branded companies, they have more defects, and a branded company, they have a less defect. Why? Because of testing, because of observation, and because of evaluation. They have to find out each and every part they have a different kind of quality testing part, right? Suppose the stitchings, they have materials, they have, right? They have a different kind of color combinations, then color qualities, right? So they have a different types of testing phases. So after testing that, that can be finalized. So similarly, once you will have a model, sometimes depends on different kinds of model, your data may have a different test data, right? So you have to remember that things also. Now the same data is tested for a particular model may not have the same kind of performance in other model. So you have to evaluate, you have to find out the performance of that data with respect to the different kind of model, right? So it is important that no observations from the training set are included in the test data. So directly you cannot have from training data to test data. There should be a phase to make some process of evaluations or finding the testing phases. You can conduct that. If the test set does not contain the examples from the training set, it will be difficult to access whether the algorithm has learned to generalize from the training set or simplifies or memorize it. So now the point here is we have to test it. Suppose I have 1,000 data. Out of 1,000 data, I have tested 300 data. And to some extent, you will find that training data, 300 data is available in the training data. That means there will be a need of getting training data to our model. Got my point? So now here in mathematical part, you can see the training data is a subset of your, your tested data must be a subset of your training data, right? And if you will combine training data and testing data, it must be your complete population. Complete population. Last lectures we have completed different kinds of populations like mean population, median, populations size, different irrespective of different context. Okay, so we can make different types of sampling size also, samples. So population samples, these are the things, discussions we have earlier we have done. So now here the part is, if you combine training data along with that tested data, it must be a universal set or it must be a complete set. There may be. So here the point is, tested data must be a subset of your training data. That means to some extent, not all the elements, but a few elements must be there in this. Excuse me. Next we'll have overfitting. That is also part of your evaluations and your evaluations of your data sciences, right? Overfitting. Now data overfitting means what? So we have three different kinds of, here we have seen, right? One by one we can go for this. Now come to this part. A program that generalizes will be able to effectively perform a task within a new data set. Overfitting, exactly, right? Exactly the output fits to this, right? In contrast, a program that memorizes the training data, here the training data also comes, so memorizes the training data by learning an overly complex model could predict the value of responses variable for training set accurately, but will fail to predict the value of responses variable for new examples. Now, sometimes what happens? Now, few set of data, which is trained data, which fits to a particular scenario, but there may be, if you will take a new data set, it may have different kinds of responses. That means there may not be predict exactly. Now, for example, if you will ask a vegetarian people, right? Those who are having vegetarian, they used to have some like different kinds of different food preferable, right? So they prefer only vegetarian food. If you will ask about vegetarian people, they can give you a well said, okay, vegetarian, these things, that things, they can give a bad pros and cons of what you call vegetarian food, right? If you ask people to a particular non-vegetarian people, They used to also have a vegetarian food, right? They also use vegetarian, they can have also non-vegetarian. So they can have a good idea of a non-vegetarian people or vegetarian people. They can give a clarity result or answers to you sometimes. Now here the part is a person who is fit for this particular answer, though he is very good at your food or preparing the food, they may not give you exact result or answer. So now you can predict here, you can fit which data set is fit to this particular context. So that is how the concepts comes overfitting or underfitting problems, and good fitting also sometimes. So now here the part, this diagram indicates, see here, if this is a line, this is a regression line, we have functions, right? So now we can underfit, we can see, depends on the training data, okay, it may not suit, it may have this particular under this line. That means whatever the decisions will take, what are the results will have, that it will not suit for this, it is under this particular decisions, right or not? Now fit, exactly it matches with the line, that line, right? This is a, suppose this is a functions. Now and over, that means more than the predictions value, you can see here the over limit of this. So over fit, high variance, good fit, low and low variances, you can see low bias or low variances, and under fit, high bias, right? So now over fit, good fit and under fit, these are the three categories you will have when you are having a training data to a particular data model, right? So that can be, you can evaluate, it helps you to evaluate also. A program that memorizes its observation may not perform its task well. Sometimes a program that memorizes its observation may not perform its task well. It could memorize relations and structures that are noise and coincidences. Now here the point is, sometimes what happens, though the data is fit to the particular model, but model predictions or sometimes results may not give you the exact result, or the result may not be the exact result. So what will happen here, that particular task of whatever the observation you have taken, that cannot be fit for that, though it is good fit, but if you will see the result, okay, so that time there may be a chances of getting disturbances or noises. Balancing this, we call it that is overfitting, underfitting, or that is these are the things, balancing, underfitting and overfitting. We can have a mechanism that we call it regularization. So regularizations can be applied many models to reduce overfitting situations, right? So now we can use different kinds of techniques here to fit the data and to get the exact data or result out of it. Next, you will have validations and holdout sets also method, right? So validations, you can see normally in software engineering, as MCA students, you are in MCA, so you might have come across validation, verification process. So verification, validation process, as the experts do that, right? Testers do that. So after completions of a particular tools or a model, so that time we can go for verification and validation. So here also we can go for model verifications, right? So now in addition to training data, we have completed testing data. A third set of observation is called validation or validate data or validations, or hold out set data is sometimes required. Now what is this? We will go for this. Validation and verifications, these are the two important parts we have seen in our software engineering when we go for software testing process, right? So similarly, here we can have a training data sets or training data, testing data. So similarly, we can go for validation process to validate the data. The validation set is used to tune the variables. Now the what is tuning? Already one part is there in tuning also. Now normally what happens? Different types of techniques used in database, tuning the database, tuning the data, tuning the what you call query. Okay, what is exactly how do we tune it? You make it proper so that exactly. Now imagine I'll give you a real example. You might have observed radio. Radio we used to play songs and all. We adjust the channel, right? We adjust the channel like 90.8 to 93.7. So we have a different kind of a frequency modulations, right? Right? Frequency modulations number we have. So we have to tune. At the earlier days, people used to listen the radio by adjusting a volume, right? A volume switch. Okay, so they have to tune it properly. Otherwise, because that was the mechanism, that is analog process. Like one stick will be there. It will adjust the number, right? We have to make it very smoothly. We have to adjust it. Nowadays we have a digital radio, so no need of this. We can directly type the number, right? That like 97.3. But that 97.3, that number should be tuned in such a manner in analog process in the older days. So it must have a exactly, not exactly. It is approximately the range will be similar to that. Then only the clarity voice or clarity audio voice can come out, right? So now here we tuned properly, or we make it such a manner that the voice will, whatever the voice will come out, it must be well audible, right? So now the point here is tune. We adjust it. Sometimes we will make adjustment improper, so the tune may be disturbances or noises you will have, right? The voice clarity or the voice quality, you may have a different types because of the tuning process, right? So that's we call tuning in the real sense, right? Now come to our context in this database. For example, I have written a query, or sometimes the people, those who are working in the MNCs and software development companies, they used to write script, different types of scripts, languages, depends on different languages, they used to have different kinds of scripts. So now what is that script? Because set of queries we have, that queries must be in proper format, it must be tuned properly. Okay, sometimes you will find a number of queries works same output, they can have the same output, but we need some tuning process. What exactly this? Now when we are going for tuning the database or query, tuning the query, that time what happens actually here? We have to see time optimization process, memory optimization, right? Everything you have to see how much time it takes. Now same output you are getting. If you are writing a code with 100 lines, that is addition of two variables, right? Two numbers, add two numbers and give the sum of two numbers. Now the same query can be, or same query can be differently written, and it must have a 10 lines, and the same output can have with 2 lines or 5 lines code. So now we have to here use as per our different context, right? We cannot go for a lengthy code, we cannot go for a complex code, we have to tune it. You have to tune it. So this is how we can, in a database query, we tuned the different queries. Now for example, we can use joining statement. You might have come across Oracle, right? So joining statement, we can use subquery. So what is the difference between joining and subqueries? The same output you will have. Suppose if I'll say display all the employees name and department's name, and both are different tables, information is there. So you can use subquery also. Within query you can write another query, and you can use also joining. So now the company, the software people, what sorts of queries they use or they prefer, that is important. So through different types of context of evaluations process, validations process, we can find out this query is not suitable, though it gives you the right output, right or not? So now here the context is different, context will be there, different dimensionality will be there, different variables will be there to judge whether it is tuned properly or not. Now it depends on experts, right? So they will decide. So validation set is used to tune the variables. Now we have a different kinds of variables. Already we have studied in our research different kinds of methodology, right? Variables we have, you have to tune it, called hyper parameters, right? We have a parameters, you might have come across in programming languages, parameters. Here we are not talking about parameters, we are calling it as a hyper parameters. Now it is some extent it is tuned. Now for example, out of now if I have a date, right? Now in date we have three different format. Like day we have, like we have what you call, we have a month, we have a year. Now if I put day, year and month in our data set, is it concrete? It will be very what you call very common structure. Now if you tune it, just you make it DD YY format, and only DD YY format, everything will be there. No need of separating this. Now separated data make we can make it tuned properly variables, that is called, for example, joining date. So now employees joining date, it's a date format. If I'll put date separate, like day separate, like a month separate and a year separate, it looks very odd, right? It cannot give a quality look, right? But when I'm making it like a joining date with DD YY or YY DD format, any kind of format, that is called, this particular variable, this particular column, this particular attribute becomes tuned, So now this is a simple example I'm giving, which can be understood easily with a short span of time, right? So you can go for database tune. Now database tune, we can see the performance, we can see how many at a time, how many users can be connected, and at a time how many data can be fetched, and when we are having a concurrency transaction, how it performs, how it gives you a better performance. These are the part of in your database tune. Similarly, when we are going for model testing, that is our context in data sciences, model testing, that time validations comes. That time we have to see also all the attributes, all the variables must be properly tuned and properly whatever the parameters. Suppose for example addition of number, additions of character value, right? Two different things. So here we have to tune properly. So that can be used. Now sometimes if you have an alphanumeric value, so how can you adjust in the parameter list? So that we can see through tuned variables process, right? That we call hyperparameters also, which controls how to model it, learn, right? So now basically we are giving the data to our data model, and the data must be very accurate for that. So next, the program is still evaluated on the test set to provide an estimate of its performance in the real world, right? Program is still evaluated, right? So now the complete whole process must be evaluated on the test data, whatever the test data is there. Now sometimes what happened, training data is there. Through process we have a tested data. Now by taking also tested data, we have to find out the performance of the machine, performance of the model. We have to check it. Its performance on the validation set should not be used as an estimate of one model's real world performance, since the program has been tuned specifically to the validations data. So we cannot see only the result, we cannot see only the test data and training data, and we cannot make a particular model is the best model. We cannot say. We have to see different kind of performance with the real world sense, with the real world approach, right? And we have to see that it has been tuned accordingly. Now depends on, now for example, if I'll say you take an example, a real example. That is, we have a different kinds of blood pressure machines, right? To test the blood pressure, right? BP machines, right? Blood pressure machines we have. If if you are working, if you are moving, right? So that time different you will have. Even if you will have a different postures, like if your arm is left side arm or right side arm you are using, different kind of value will have. So now, if you will have an exact value in both the cases, both the senior situations, scenario, so that time you can say this is the best model, this is the best what you call product, right? If it varies a lot, that time you cannot trust it. So that's my actually I wanted to share. That is the real performance you have to evaluate until unless you have tuned it properly, until unless you set it properly, until unless you manage it properly with all situation, right? Right. So now sometimes you can see another example I can say. This are real examples. Astronauts. So now you might have seen different kinds of visuals, right? In WhatsApps or in internet, you might have seen the astronauts, those who are ready for going for research work for space research, right? Suppose 2 or 3 or 5 astronauts they are selected for sending to the Mars or to the moon, right? So they have to put into a observation, and NASA always put these astronauts in a particular environment where they will find like moon atmosphere or that type of atmosphere they will have where they are going to, right or not? So now they have to pass it, they have to complete this process, otherwise they cannot move to the different space okay, so missions. So now when they have all these tasks they have completed, then they can go for the space missions. Got my point? So you might have seen different kinds of plays or different movies, that things also it is there. Like you might have seen Deep Impact, one movie. So in that you can see how the astronauts they adjust their atmosphere and different. Though they have already trained, but they will have a different kinds of situations on that, because we cannot have the control of external environment, right? So we cannot have, so different types of situations may comes, but our machines, our what you call model must suit for that. So that is actually validations, what we call, or we call it holdouts. Okay. So now you can see in this particular standard holdout method, data, training data, holdout data. So now by using this, you can make here next further. This is here analysis. That is the top people, those who are taking this data, right? They can be once they can be used once or unrestricted access, right? So now here hold data. Sometimes you might have seen these are the holdout data, means that is already once it is completed, right? So several methods they have, one process they have completed or it is tested already some extent, but is on a hold. We are keeping hold. Like you might have seen hold out. That means few students in placement cells you might have seen, they are on hold, right? Hold out data means already they have come across, they have tested, but few situations or depends on different kinds of decisions, so they are holding positions, they are keeping, right? So now in this scenario you might have a different kinds of data like training data or holdout data, and which can be used in the model, and different situations that can be tuned and that can be used. Okay, so this is how we use tuning process also, and you use different kinds of data like validating data also we can see. Next, cross validations, out of which you will have find cross validations also, similar kind of validations we can see during the development, a particular and particularly when training data is scarce. That means lack of training data, right? A practice called cross validations can be used to train and validate an algorithm or the same data. Now cross validations, right? Cross verification, cross validation, right? We do in our software engineering also. In cross validation, the training data is partitioned. We have to separate it. You have to set different kinds. Suppose a set having 1, 2, 3, 4, 5, 6 till 10, and we can make this different group like 1, 3, 5. There is odd numbers, even numbers, like similar kind of groups you can make, or different partitions you can go for this. In this, in cross validation, the training data is partitioned. The algorithm is trained using all but one of the partitions and tested on the remaining partitions, right? So now here we have a different kinds of partitions we can use for training purposes, and we can test it, and the remaining partitions also tested through this process. So cross verification, once it is tested, okay, we'll see the next part. We'll see the next part. So this is cross verification. So we can find out here. You can see here the structures. You can see parameters, variables. We have different cross validations. Now under cross validations, you can best parameters. You can find out. Now out of normally we cross verify. Suppose if you want to know know about a particular persons, right? You can find out different types of data from differently, right? So you just verify, cross verify, right? So he is saying this person is very good. This person he is saying X is saying is very good. Y is saying is a good person, and Z is saying he's not a good person. Now here the different kinds of situations comes. These are the different kinds of partitions you have. So one is very good, one is good, another one is worse. So now you have to cross verify and find out the best one. Find out the best one. So best parameters you can find out. Then retain the model. Then once you have parameters, that means you are cross validated. Then you can go for sending to the model that is your whatever the models you are using, especially for machine learning model. You can give that. Right. So now this is how we can use cross validation process. Now in this particular we have one example. So you can see, consider for example that is original data set is partitioned into 5 subsets. Now for example we are taking a complete data and we are dividing the data set into 5 partitions, equal partitions, right? Labeled A, B. We are giving A, B, C, D, 5 partitions we have through E, right? So now 5 partitions we have A till E. Initially the model is trained on the partitions B and through E, and test on the partitions, right? We can have a next model that can be partitions A, B, D. So similarly different kinds of partitions we can test it, we can cross verify each and everything we can make by combinations, by partitioning this. Partitions are rotated until the models has been trained and tested all partitions. Now we can make all partitions testing, okay? So once it is completed, then we can go for the selection process of which can be used. Cross validation provides a more accurate estimations of the model performance than testing a single partitions of a data. Now normally what happens, we have a concrete data, and we are putting into the model. What about the performance you will have, what about the result will have, it will be less compared to less qualitative. But if you will go for cross validation, because each and every time if you will make partitions, or sometimes what happens in normally in our software field it happens. Now you see checking or testing the code, testing the output, always it varies in different types of combinations or different modules combinations, right? So you have to cross verify and you have to find out the best one, or which combinations is good, or which impacts a lot and which affects a lot, right? So you have to find out which model or which part, okay, because of this part it hampers the complete result, right? You have to find out and you have to evaluate also. So this is also one very good what we call for our model performance. If you are evaluating a model, if you are evaluating a performance of a model, cross validation is also a very good tool or techniques which can be used for our evaluations process. The next you will have a bootstrap method that also for validations and performance evaluations we can use. Bootstrap is a powerful computer-based methods for statistical inference without laying on too many assumptions, right? We cannot take too many assumptions here, right? This method is used for estimating the quantities about the populations by averaging the estimates from the multiple small data samples. Importantly, samples are constructed by drawing observations from a large data sample one at a time and returning them to the data sample after they have been chosen. Now, here the point is we use normally in research methodology. You might have seen we use samples. What is sampling or samples techniques or what is populations here? These are the two words already we have completed in the previous topics also. Populations, mean population. These are the things we have covered. But you can find out once again. I am telling the method of estimating the quantitatives about the population. Now, suppose if you are predicting something, suppose if you are inferring something, suppose you are concluding something or just giving some final decisions. So now you have to always see your what is the population and what is the sample we are taking to take the predictions. Now, for example, if I'll predict a particular things now recently we have seen that we have different kinds of viruses infections, right? So now you can see delta viruses. You might have seen one variant of your COVID, right? Coronavirus, right? One variant. The second is we are having different kinds of latest we have what do you call them? That different kinds of viruses is coming. Now, just if you compare it, okay, by observing a few states, by observing a few people, right, we cannot predict the symptom. We cannot predict the symptom, general symptom of your a particular virus, right? So now you have to see that a small amount of data or small amount of observation, which is called samples, it inform or it conclude a large amount of data or it conclude a large amount of data. That time we call it the sample and populations, right? So now in this particular computer based methods, that is bootstrap methods, right? So in this particular we have to see the quantities of population. How much population? Suppose you have 1,000 people and you are predicting by taking the 10 people's data, right? Here the 10 data must be accurate observation which can give you each and every 90 people's data accurately. So that can be possible. Here we cannot take too many assumptions, we cannot take too many data, we can take a small amount of data which is appropriate and which helps to give you a particular estimations or a particular decisions or a particular conclusions, right? So that things can be used when we are validating or when we are evaluating the performance, sometimes these cases. But in computer science we have a different kind of methods, so we can use different techniques also. So bootstrap sampling methods also we can use. That is basic idea for bootstrap is to make inferences about an estimate such as a sample mean. Already we have covered mean, sample mean for a population parameter, that is uh, theta, such as a population mean on the sample data. It is a resampling methods by independently sampling with the replacement from an existing sample data with the same sample size n and performing the inference among these sampled data, right? Now you can see here, I'll show you the mechanism here. So now this is how the complete populations, you can see here original samples with the sample size. So now these are the sample size we have taken, right? This much of mobiles we are using, smartphones. So now here we can take B sets of bootstrap sample size is n, and you can have n number of B sets of bootstrap estimates is B. Theta, that is B. You can see here in this particular phase. Now we are taking 1, 2, 3, like till n, or we have n number of samples we are taking, and finally we are estimating the value, right? And by estimating all this value, we can make a further inference. Now here what happens here, you can have a rather one sample, one inference from populations, right? It is better to go for n number of samples, n number of estimates, and a final inference. That exactly Bootstrap had. So Bootstrap means we have to make n number of sample. Instead of going, normally what happens, we take one sample. Okay. Now, for example, out of 1,000 people, we can go for suppose a particular method of sampling. Suppose a random sampling, right? We have a quota sampling. We have what do you call different kinds of sampling techniques, right? Convenient sampling we have. So now, suppose one sampling technique, by using one sample technique, okay. So we have taken suppose 100 or 200 people's data we can collect. Now this is one type. So you can take n number of type samples and you can get data and you estimate. That also one good type of evaluation system maybe. So now this is how we can evaluate the sample and estimate the estimate. We can estimate some and through different kinds of samples, and finally we can take a decision. So this is how you can see bootstrap method. So now here the normally what happens, one that means a population out of which one sample we take, but here the bootstrap method takes multiple samples, okay, data samples, so that we can have an appropriate inference, appropriate decisions, or appropriate conclusions we can have. So dear students, this is next we will have these discussions. Because of time limits we cannot cover. Now we are going to stop. Now today we have discussed about just once again I'll just show you what are the different contexts we have done. Now these are the things we have: training data we have covered, and testing data. Then we have covered overfitting. Now we have 3 stages of like underfit, overfit, and a good fit. So now then again we can go, we have completed validations method. So hold out set data set. So also it is important for our validating the model. Then cross validations we have completed, and examples we have seen. Then methods of bootstrap. It's all about your evaluations and different kinds of methodology we use for data sciences, when especially we are going for evaluating the different types of model, right? So now this is how we can use different kinds of method in our different kinds of model, like machine learning model. We have artificial like neural networks model. We have artificial intelligence. We have data mining, data warehousing, different kinds of model we are using. So to evaluate, to test that, we can use different kinds of methods. I think you might have understood all this concept of what I have taught, and thank you for this particular video, right? So you can watch regularly all these videos and all these clips, so that you can clear your doubts also. So next time we will discuss the next part of this data sciences. Okay, thank you, students.